Welcome back. This is Santosh again for the lecture series on artificial intelligence and cognitive computing. This is lecture series 2. In this lecture series, we'll be discussing about various applications of artificial intelligence and various tasks by the artificial intelligence. First, we'll start with the applications of artificial intelligence. Artificial intelligence has found n number of applications. To name a few, it starts with gaming. We play right from the PUBG game till n number of games we are playing with the help of artificial intelligence. The game, chess, poker, TikTok, etc. All these things where the machines need to think and give some solutions, artificial intelligence are being used. Second one, natural language processing. It is possible to interact with the computer that understand natural language spoken by humans. Humans do spoke a single language in different slangs. Different type of people will use different types of slangs for expressing their views. So a machine need to be able to model in such a way that it can able to understand all the natural languages. So natural language processing. Next one, expert systems. Here, for various reasons, we'll use integrate machines, software, special information to impart reasoning, advising. Even the counseling can be done by the use of artificial intelligence. Next application is the vision system. This is one of the major applications of artificial intelligence where we are having n number of applications right from a spying aeroplane, like a quadcopter. We have seen many quadcopters with a cameras installed with that. It will able to figure out anything which is fishy and it will able to give us a report. Second one, doctors use clinical expert system to diagnose the patient. So doctors can able to analyze the patient's condition using some sort of machine learning, thereby artificial intelligence. And policemen can use computer software that can recognize the face of a criminal with a stored portrait made by a forensic artist, which means that a forensic artist can make a picture, can draw a picture, and that picture can be matched with the pictures which is already available in the computer software. It is nothing but your face recognition. It is one of the good application of the artificial intelligence. Next one, speech recognition. As I told you, it is similar to that of natural language processing, because the model what we are going to do will able to handle different accents, slang words, noise in the background, change in the human voice due to cold, cough, throat infection. All these things should be able to handled by the artificial intelligent machines. For example, Alexa is a artificially humanoid bot which will able to give us the answers for our questions. Okay, for that machine, if even though if we have a call, it should be able to recognize our voice. Such applications are taken care by the artificial intelligence. Apart from this, we have something called as handwriting recognition, because handwriting of each and every person will vary from person to person. No two handwritings will be the same, so we need to have machine which can able to understand the handwriting based upon whatever it may be. It may be in a slighter way, or it may be strongly written, or it may be curved written. Whatever it may be, it should be able to detect if it is A should be like this, A should may be like this, A can be written like this, A can be written like this. Whatever it may be, it should be able to understand it is in A, not a U. Finally, we have an intelligent robot, iRobot, which can perform the task given by a human, which means that any number of sensors will be deployed in that robot, which can able to get data such as light, heat, temperature, movement, sound, bump, pressure. All these things will be built up as a program for a robot. Okay, all these are the very good applications of artificial intelligence. So we'll summarize once again. So artificial intelligence applications includes gaming, natural language processing, expert systems, vision systems, speech recognition, handwriting recognition, intelligent robots. All these are the very good applications of artificial intelligence. It is clear for you. Next section, we are going to move into requirements of AI problems and solution techniques. What are the requirements for AI problems and what are the solution techniques? First one, understanding the assumption about the intelligence. Second one, techniques for solving AI problems. Third one, level to model the human intelligence. Last one, criteria for success. Okay, I will make it like this. First, we need to assume something. For example, if x plus, we need to assume that x plus y equal to z. This is our assumption, right? X plus y is equal to z. We don't know what is x, what is y, what is going to be z, but we know that x plus y should be equal to z. We have assumption. Next, once assumption is done, then we need to find out the techniques to solve this problem. We have now found a problem, x plus y we should be equal to z. Now we need to find out the solution techniques. Once the technique is ready, then we need to model our machine. We need to model our machine. Once the model is done, then we need to verify the success rate, because unless we have some sort of threshold, some sort of criteria to measure the success, we'll not be able to understand whether we have really built a humanoid machine or we have built a machine which is just look like a human but it won't behave like a human. Whether your machine is really intelligent machine or not an intelligent machine, we should be able to analyze. So again, I'm giving you briefly. First, we need to assume something. Then for this assumption, I should use some sort of AI techniques for solving the AI problems. Once this has been done, then we need to level to model the human intelligence. We need to model it. After modeling, we'll be able to check for the criteria for success. These four are main requirements for the AI problems and solution techniques. We'll see one by one today. First, we'll start with the understanding assumption about intelligence. First one is understanding the assumption about the intelligence. What does that mean? Understanding the assumption about the intelligence. The underlying assumption is physical symbol system hypothesis. What is this physical symbol system hypothesis means? For example, if I take an English language, symbols are nothing but the alphabets are nothing but the symbols. Okay, the expressions are nothing but the words and sentences. The processes are nothing but the English. So once all these alphabets are combined together, will form a words, and these combined together will form a sentence. Completely will have some sort of process. Complete thing we call it as a process. This is nothing but the physical symbol system. It is just an hypothesis. Okay, that is nothing but we are assuming. Hypothesis means we are just assuming. This assumption may be true, may not be true. If it is, if you don't want to accept it, then prove that it is false. Otherwise, the hypothesis you need to accept it. Clear? Now, what is this? First, we need to assume something before dealing with the solution for a problem. Now we have assumed something. Then next we need to find out some sort of techniques for solving the AI problems. Okay, what are the techniques should be used to solve the AI problems? Because artificial intelligence, I told you earlier class, earlier lecture, I told you that we have a lot of data. The data is nothing but data is very huge. it is very difficult to characterize correctly because it is like a garbage bin. We have n number of data. It is very difficult for us to characterize correctly, and it is constantly varying. Okay, what is constantly varying data? Like if you take a problem which is prevailing now, it is COVID problem. Okay, so scientists, what they will do, they will take some data. Okay, we have a problem, COVID problem here. They will take some data. This data may be like persons, from 1,000 persons will have fever monitoring, cold, okay, cough. These are the symptoms I have taken. These are the data for 1,000 patients, and I'll be modeling a machine, okay, to analyze this data. And if a new person is being tested with the available data, I should able to give whether the person is having a COVID or not. What happened after few weeks, we'll have a new symptom which we don't have it in our database because it is constantly varying. So I need to again add something called as, see if it is diarrhea. If I have a diarrhea, again I need to check with all these things. I need to rearrange all these things. So the data is constantly varying. Okay. Next, last one, differs from data being organized in a way that corresponds to application. Last one, it is complicated. So these are the very high challenges I need to face before defining some sort of techniques for solving the AI problems. Now we'll start with the techniques to solve the AI problems. We have three types of techniques. First one is the search mechanism. Second one, use of knowledge. Last one, abstraction method. Search means when there is no direct way to get a solution, we'll go with the search mechanism. For example, see, we have a here. Okay, I need to find B here. Okay, I have a direct path from A to B. This is, I have a direct solution to find out where B is. If suppose, let me take a problem where A is here, B is here, okay, C is here, and E is here. Okay, I need to find a path from A to E. I need to find a path from A to E where there is no direct path from A to E. In this case, I must use some sort of mechanism to find out the desired output. So this is called a search mechanism, which means that, see, it is clear, this technique provides a way of solving problems for no more direct approach. When there is no direct approach available, we need to go with any indirect method to solve the problem. It is nothing but the search mechanism. Second one is use of knowledge. Like if we have some predefined knowledge about a problem, it is easy for us to find a solution. For example, if I need to make a robot for playing a chess against a human, I know the conditions for chess. Yes or no? I know the conditions for chess. With these conditions, it is very easy for me to write a program and execute it. So use of knowledge. So third one, abstraction. Abstraction is nothing but we can able to categorize the features into very important features and unimportant features. And important features can be considered, and unimportant features can be omitted. For example, the task is to detect a face detection process. The main parts is eyes are very important, and nose, and then mouth and ears. These are very important. Other parts can be omitted with these part because these are very unique parts for a human being. So with these parts I'll be able to form a solution for this. This is called as abstraction method. So we have three techniques for solving AI problems. First one is a search mechanism. Second one is use of knowledge. Last one is the abstraction method. Don't forget, we have three techniques for solving AI problems. They are search mechanism, use of knowledge, abstraction method. Is it clear now? We'll move on to next one. Third one is what? Level of model. So now we have assumed something as the first point. We know some sort of techniques in the second point. Third one is level of the model. What is this level of the model? What is the level of the model? What is our main goal? What is our main goal? Are we trying to produce programs that do the task the same way that people do? Or are we trying to produce programs that simply do the task of the easiest way that is possible? Like, we can build a program, we can build a machine which can do the task just like a human being. Otherwise, we can build a machine which can do the same task in a simpler way. For example, if I say that if I need to walk from the third floor to first floor, a human being may take steps and then walk from the first floor to the ground floor. This is a human way. The machine, what it can do, it is an intelligent machine, so it can just walk to the lift and find where this is the lift, and it will take the lift and then move down quickly. This is easiest way to go down. So these two ways, whether are we really trying to produce a machine which will do the same task what humans do, or the same task in an easier way. We need to think what is our objective, what is our goal. Accordingly, we need to build the machine. Okay. Last method will go. Last one. See, this is a example I have taken. Case one. First case is nothing but we are just giving the machine a program to memorize and then give me the answer. Okay, I am giving all, for example, let me tell that I am building a robot to memorize all the multiplication tables from 2 table to 16 table. It is memorizing from 2 table to 16 table. Okay, if I'm asking 8 into 2, what it will give me immediately? 16. It will give me 816. This is nothing but the first case where we are just giving some task and then making it to memory and then come give out. Okay. Second case, I'm giving a newspaper. I'm giving a newspaper to the robot and I'm asking the robot to completely read the newspaper. At the end of the newspaper, okay, after reading completely, I will ask the newspaper, I'll ask the robot, why did the terrorist kill the hostage? This is very twisty, right? I have given a newspaper. The computer has read a complete newspaper. At the end, not asking you a computer to give me important news. I'm asking it a question. Why did the terrorist kill the hostage? In this way, the program must be written so that it will have some reasoning, simulate the reasoning process of the people, intelligent machine. Because I don't want an ordinary machine, I want an intelligent machine. So level of the model is again very important. Next, we'll move on to the last criteria for success. How to know that we have succeeded, or how will we know that we have constructed a machine that is intelligent? Okay, how to know that we have succeeded? We have built a program now, we have built a model now how to understand that the model is really a good model or a bad model? Think a second. Yes, that is, we need to judge, we need to have some sort of exam to really understand that whether we have really built a really artificially intelligent machine or some garbage machine. We need to understand, right? For that, in 1950, Alan Turing proposed a method to test whether the machine is intelligent or not. This method was then called as Turing test. What is Turing test? This is a method which is used by Alan Turing, which is proposed by Alan Turing to test whether the machine which is built is really intelligent machine or not. For that, we'll have this test. I'll explain the Turing test in the next class. With this, we are going to wind up today's class.